here.
Oh, no. 18, number 18. Wait, no, I think I figured this out.
Oh. There's an unfolding story there. So you're good?
Number, I don't remember now.
All right, I'll let you look it up.
Yeah.
Really quick. So, can you do number 11 on 5-1? You corrected it here.
Okay. All right, so the correct answer to this is -8. This is true. But if your work is this, then I'm going to know it.
Why?
Because it's not what it says.
Which number was that?
11 on 5-1.
So help me out. You ready? You ready? You ready? Everybody, do this problem. Yeah, you do. Yeah. I didn't say tell me about it. Maybe. Welcome back to math. All right, so what do you got? 45, okay. Because what's order operations say? You do exponents first and then you multiply. Now, this 5 and this negative are the exact same idea. They're both coefficients. What am I squaring here? The 3. What am I cubing here? The 2. So what do I have 3 of here? So, I'm sorry, 5 times 3 squared is 5 times 9 is 45. Okay, that's what you all should have got. So this is not right. This is negative times 2 times 2 times 2.
Did we ever do that?
Of course we did. I talked about the difference between this
Okay, yeah,
and this, and it's the same exact thing. Yeah. Here I'm squaring a negative, here I'm squaring a 2, and there's a negative in front of it. Now here, the answer comes out the same either way. So as a student, the most frustrating thing for you and me is you're like, I got the right answer. I don't give a shit. Right? The answer doesn't matter as much as how you get there. So if you do the same thing with a 4th power, you would be wrong. That's what's more important, is the process you apply always work. If not, I've got to take points on it. I don't care if you get the right answer or not in that specific instance. You just got lucky if you did.
Even if, would it, because they're, okay, I got the right answer, but maybe a different reason, because if you were doing the -2 to the 3rd power, if you were doing it all together, there would be 3 negatives, and that would make it negative now.
Yeah. In this case, this and this, they both have the same value. Because if there's 1 negative, it's going to come out negative. If there's 3 negatives, 2 of them are going to cancel. It's still going to come out negative. So you got lucky.
Oh.
There is only 1 negative in this problem, though. If you wrote more than 1 negative, you're wrong. I really want you to see that. Even though the answer comes out right, you got lucky that the answer came out right. If you do this, if you do -2 times -2, -2, -2, what do you get? 4 times 4, 16. That's not the right answer. That's not the right way. Because how many negatives are here? 1. There are 4 2's. This is negative times 2 to the 4th. So if I wanted the answer to come out to be positive, so here the answer should be negative 16. If I wanted the answer to come out to be positive 16, what do I have to put in there? Parentheses. Then I can say I got 4 B's. Now that would be the right work. All right. I like it. And this is the grammar of math. This is like when I was in English class, and my English teacher gave me a bad grade and said, "Did you understand what I was saying?" And they said, "Yeah, I understand." Well, then what the hell's wrong? It's more than that, right? Did I say it the right way? This is the grammar of math, which is why it gets so detailed and technical. But just remember this, that. So you treat it the same way as it would that. That's 9 times 5 is 48. That's 9 times negative is negative 9.
I have one too.
Sure.
Number 79, 5.1.
Oh, yeah. All right. Bless you.
79,
Bless you.
5.1.
Thank you.
Wow.
No.
All right. I won't do what I was about to do, but I don't know if you've ever seen the proof of the area of a circle before. Did I show you that?
No,
What is the area of a circle?
RC2?
Yeah, if I give you, no. Pi r squared.
Yeah.
I like pi r not squared, pi r round. One of the millions of bad matchups. So then they give you, what do they give? What's the radius in the one they give you in 79? They give you this. So what is 3x squared for that circle? What is it? It's the
Radius.
It's the radius. So r is 3x squared. So where do you put this?
Behind the pi.
Inside here. I mean, so if I had a circle that had a radius of 7, what would the area be?
72. 71.
Oh, so it'd be pi r squared, and what's the r?
7.
7. So it'd be 49 pi, and you can put that in the calculator so you did it. Right? So whatever the radius is, I don't care what it is. If the radius was Tony, what's the area of that circle?
Pony.
Tony squared.
Oh, Tony.
Hey, Tony. Squared. No, you're not. Sorry. So, if the radius is 3x squared, the area is pi times 3x squared squared. Pi r squared. I'm just replacing the radius with what it is. Whatever the radius is, what do you do to it? You square it and then multiply by pi. That's what this says. So now you just got to simplify this.
Oh, that's what I
Yeah,
was
so you square the 3, you square the x squared. Well, you had to start with knowing that that was the area of a circle. And if I remember correctly, I think they have all the back of the book. Yeah.
It did have the answers, but I
No. They have the area formulas in the back of the book. If you forgot the area of a circle or whatever, trapezoid or whatever they throw at you. Yes.
Maybe number 78 on 5.2. Page 3.
I don't know. Let's see. Oh yeah. So, all right. Let's break this thing down. 78 says, write a polynomial that gives the sum of the areas of a square having sides of length x. Okay, let's stop right there. A square, sides of length x. And where to go? A circle with diameter x. So with the areas, with the sum of the areas. So what's the area of this square?
Side by square.
X squared, 11. Right, length times width. Now what's wrong with the circle they gave me based on what we just talked about? What is it that I need to know about the circle? The radius. And what did they give me? A freaking diameter. Dorks. So what's the radius going to be? Yeah, this is going to be, sure, 1/2 x. And what's the formula for the area of a circle? Pi r squared. And what's r? And I could write like x over 2. That makes it a little bit easier to work. So it's all about, I went a little too fast through that problem, but it's all about capturing, and this one was involved 2 pieces, right? It was a sum of 2 areas. So you think about each area separately. You don't try to throw it all together. You don't make too much of the problem. It's just find the area of a square that they gave you, add it to the area of a circle, and you say, okay, they didn't give me the right thing about the circle. So I have the radius. Okay, get the radius. And anytime you have the radius of a circle, I don't care what it looks like, you square it and multiply by pi to get the area. That's what you always do.
And then so for that problem, we substitute for the x's of the 6.
Yeah, so the second part is just plug a 6 in. Yeah. So simplify this. And then that's like part A, and then part B was plug a 6 in for x, yeah. Real quick. What shape are silos in? You know, that hold peanuts or grain or whatever? Cylinders, right? So there's a circular base to that, right? So what's interesting is the circle shape holds the most stuff for the same amount of material. So if I wanted to make something with a certain amount of material, I would maximize how much I could hold by using the shape of a circle. If I use the shape of a square, it could not hold as much based on how much material I used to make it. I don't know if you guys are kind of with me. So people kind of found that out naturally, and then math said, oh yeah, you're right. You should use a circular shape so that the material captures the most amount of volume. That's all side stuff, I'm sorry. You're like, it's too early for that, Jeff. Too damn bad. All right. Yes?
5.3, question 82, page 323.
Will you type in that?
Probably did it right before spring break.
Yeah, that sounds familiar, right? Did we look do that problem?
No.
Rectangular garden has a perimeter of 500 feet. Yeah. And they tell you if one side of the garden has length x, write a polynomial expression that gives its area. I love this problem. I would. There's so much in there. So it says write a polynomial expression that gives its area. So what am I missing that I need to know? I need to know what the hell this is. You guys with me?
Yeah.
So the area is going to be whatever x times whatever this is. I don't know what that is, so what can I call it? Sure, I like it. You can call it W. You just can't call it x, because then I'd be saying I was squared. I don't know that. Use some other letter. Now, now watch this. This is interesting. This happens in higher level math too. They tell you something, and then they ask you something. They told me this. Well, what's the formula for that? What's the formula for what they tell me?
Length by
Careful. Perimeter.
perimeter.
Yeah.
Yeah.
2 W's
2W.
and 2 X's have to make what?
500.
All right. So that formula is just, they told me 500. They gave it to me. So that formula I can write without much work. I just had to give that side a letter. So 2 of those sides and 2 of those sides have to make 500 because that's what they said. They tell me that. What did they ask me about?
Area.
Area. What's the area for this the way it is now?
W by X.
Yeah. Did they actually tell you this? They don't tell you. They should say this. But let's see if you guys understand. There's too many variables here. There didn't have to be this many variables. Because X and W have to do this. So if you let X be something, W is going to be a certain definite thing. It can't be anything it wants to be. I don't know if you guys see. So can I get rid of this W somehow? And I don't just mean erase it. There you go. Can I replace this W with something? What can I do with this to figure out what W is?
2W equal
Yeah.
2X plus 5.
2W
500.
equals...
500 minus 2X, yeah.
So then what's W?
500 minus X.
Divided by 2.
Divide by-
Everything.
Yeah.
So W is?
250 minus X.
So that is what W is.
Uh-huh.
Isn't that substitution? Isn't that like... I have how many equations up here? 2. So I can use one of them to substitute in the other one. So plug that there.
Now it makes sense.
Because now in part B it said,
X.
what if X is 50? And then you're like, I don't know what W is. Well, shit, you don't need to. I just replaced W with something that only X cares about. I really want you to understand. How can I say this? I mean, if I said the perimeter of a rectangle was 100, how many sides do I have to give you before you know all the sides? What's the least number of side lengths that I have to give you something, right? Right now, I don't know. It could be almost anything. I just have to tell you one side, and then you should be able to figure out all the sides. Does that make sense?
Yeah.
So if I told you this side was 20, can you guys figure out what that side must be?
80.
Can't be 80.
No?
Perimeter's 100.
Oh, yeah. 40?
No. So those sides have to be
Think about it.
30.
It's got to be 30.
30, yeah.
Why? Because 30 and 20 is 50. Another 50 would make 100. So what I'm trying to say here is, I shouldn't need an area formula that's got two variables in it, because I only have to know one thing. I don't need two variables. I only have to know one thing, and then I know everything else. So that's why it makes sense that I should be able to write an area formula that only has one variable in it, because I only have to know one thing. What's the area of this now?
20 by 30.
Yes?
Yeah. 600.
600. 2 times 3 is 6. How many zeros do I see? 1, 2. Bam, bam. All right. All right, don't make those things hard. If they end in 0, you're like, oh, thank God, it's easy. All right. So what was this all about? I'm just trying to get you to understand why it makes sense that I should be able to do this with only one variable, because how many things do I have to be told to know everything about this? One. I don't need 2 pieces of information. I just need one. So I should be able to, now what's the area then? It's x times what? What is W?
250 minus A, so 200.
Yeah. Like Nathan said, you just take that,
Yeah.
distribute, I like it. And then part B is easy.
And yeah.
If x is 50, you just plug a 50 in for x.
200. Huh?
So, if x is 50, then we plug in 50 and 50 again.
Yeah, and replace x with 50. Everywhere you see x, you know it's 50. But you could do this. You could go ahead and say 250x minus x squared. Right? And plug a 50 in for x. Or leave it like this. It'd be 50 times 250 minus 50. Alright, I'll let you guys finish. It's basically done. What's up?
She was doing something wrong.
What's up?
What does it mean when they want you to put it geometrically and symbolically?
Where's that?
On 5.3, so that section 37.
Oh. So
give me
they.
an example, but like, does
Yeah.
it want it? Does it want it for the symbolically one too? The square?
So it's
I
like.
did it for A.
So for example, like 38.
40.
It's got 2x times x plus 5, right? And they do give you an example, right? They
Yeah.
give you at least one example. Like back on page 319.
Yeah, that one.
I like it. So then, couldn't I make a... It's not going to be squared. I drew it like it's square, but one side will be 2x, and the other side will be x plus 5. Won't that be the area? I like it. So
And then you just figure it out,
Ready?
right?
So if this is x plus 5, let me see if this is the way they did this. Yes, good. Sort of. Yes, okay. I like it. This is x plus 5, then I can say, okay, well, this much maybe is x, and this much is 5. Then how long is that side? X plus 5. I like it. So what's the area of this? X times 2x, right? So that area is 2x squared. And what's the area of this? 5 times 2x, which is 10x. So this and this is the total area, which is what you get when you distribute, right?
I did not do it.
All right, that's the example they gave you. The example they gave you is actually a little harder.
I mean,
The example they gave you was x plus 4 and x plus 3 or something like that. So you had,
I did the example, but I just literally did the problem because I wasn't understanding what it meant.
I got you. So
Okay.
geometrically is interesting. I wanted to give you a chance to do it because it will help some people out and some of us it won't. So, but I just got to throw it out there for those who it will help. If you don't quite get the geometric interpretation, is not a big deal. Because some of us think more visually and some of us don't, right? So if you get that and it helps you understand why distribution makes sense, then great. Because if I get the areas and add them together, I get what I get when I distribute. Right? That's what that's trying to show you, is there's a visual interpretation of this. If that doesn't help you, okay, you're not that kind of person, which is fine. I actually don't, I want you to try to do this, but I'm not going to be too concerned if you can't quite get this. But just the example is exactly the way you want to do this. This was a little easier because how many terms does this have? 1. So I just needed this whole side is 2x. This has x plus 5. I had to break that side into an x and a 5. Right? The example they gave you, you have to break it up into an X and a 3 and an X and a 4, and then you have this, and this. 1, 2, 3, 4 areas to add together. And when I distribute, when I multiply this, how many terms do I get before I put like terms together? 1, 2, 3, 4. That corresponds to the 4 areas. You guys follow?
Okay.
So again, some people, this geometric interpretation really kind of clicks somewhere in your brain, and some of us just don't think that way, which is fine. But you should be able to kind of work through this and see how it makes sense. What would the area of this little dude be? This little piece there, it'll be x squared. So that's the first, right? X times x. Then you do the area of this. You do the area of this. You do the area of this. 3 times x. That's how you do that. Alright, again, so that's not a big deal if you don't quite get that. It's not the biggest concern for me. But if that helps you, I wanted to give you a chance to look at that kind of problem. Alright. Anything else from homework? Okay. So what I want to do, that was a lot more questions from homework than I expected, which is awesome. But this is not quite as necessary now. Well, yeah. Out of the yellow book. So I have some copies if you don't have the yellow book. Page 130. I want you to do these. Yes. Page 130. Should be chapter 5 review. Hopefully. Who needs a copy?
Can I have one just to do another one another time?
Yes, I think.
Do you need one?